So Section 4.2, theoretical probability. So it's not always feasible to conduct an experiment over and over again, so it'd be nice if there was another way to find probabilities without actually conducting the experiment. So these probabilities are called theoretical probabilities. And to be able to do theoretical probabilities, there's an assumption that you need to consider, and that is that all of the outcomes in the sample space need to be equally likely outcomes, which means that every outcome of the experiment needs to have the same chance of happening. So it's a little weird because in computing these theoretical probabilities, you have to already have some understanding of probabilities and how often events occur to know if you have a set of equally likely outcomes to begin with. Now, unfortunately, many students carry with them to statistics this idea of if they're given two options that there's like a 50-50 chance always between those options, which is definitely not the case for almost anything in life. Okay, so flipping a coin, that's fair, 50-50 chance between the two sides, but most other things that we encounter, not 50-50. So, whether you pass this class or fail this class, not a 50-50 chance. Whether you live through the day or something horrible happens to you before the end of the day, so not a 50-50 split between those two outcomes for the day. So this idea of equally likely outcomes creates a lot of problems actually in statistics and in computing these probabilities. So example 4.2.1. So equally likely outcomes. So which of the following experiments actually have equally likely outcomes? So the first one says rolling a fair die. All right, so this word fair in here is important because this is a word that we use in probability to mean all the outcomes have the same chance. All right, so our solution here is, since the die is fair, every side of the die has the same chance of coming up. So the outcomes of the different sides are all equally likely. But now part B says we're going to flip a coin that's weighted so that one side comes up more often than the other. Okay. So in this case, since the coin is weighted, the outcomes of different sides of the coin will not have the same chance. So the different sides of the coin are not equally likely to occur. All right, now part C says to pull a ball out of a can containing 6 red balls and 8 green balls, and it tells us that all the balls are the same size. So all the balls being the same size tells us that each ball is equally likely to be picked since they are all the same size. So you can imagine if you had like a big barrel in which there was like a basketball and a tennis ball and a golf ball and a volleyball and a football and so on, you would be more likely to reach in that bin and grab, let's say, the basketball than the golf ball, because the basketball is just so much bigger. But in this case it says that all of them are the same size, so each ball is equally likely to be picked since they're all the same size. Okay, which means then that the colors are not equally likely outcomes. Since there are more green than red. Alright, and then part D says picking a card from a deck. Now when they don't specify here, this is going to be just a normal deck of 52 cards. So again, if we're just going to pick a card from the deck, again, each card is the same shape and size. So each card would have the same chance of being picked. So each card is an equally likely outcome for this experiment. Alright, and so if we go on to the last part here, so if we were going to record the marital status of each person in a survey, so if you think about this, so let's just say we asked people what's your marital status, and even if we just considered, let's say we just considered married, and then we'll just lump everything else together as something like not married. Okay. Again, two categories does not necessarily mean that there's a 50-50 split between these. And so again, these outcomes do not occur with the same frequency or relative frequency. So they are not equally likely. And for example, if we were to give this, let's say we were to interview people on campus, there would be far more people on campus who are not married than married. So again, for these to be equally likely, it would mean half the people would have to be married people and half the people would not be married people, so that these each have the same chance of occurring. So if the outcomes are not equally likely, then you have to do experimental probabilities, which, as I said earlier, is typically what we have to do for many of these statistical studies. If the outcomes are equally likely, then you can do these theoretical probabilities, where we're just going to, so our theoretical probabilities, which use something called the equally likely rule. So if the outcomes in an experiment are all equally likely to occur, then the probability of an event A happening is simply just a ratio of two counts. Okay, where in the numerator we're going to count the number of outcomes in the event space. So that's the set of all of the things that we're wanting something in that set to have happened. And we're going to divide that by the number of outcomes in the sample space. So all of the possible outcomes to that particular experiment.